Hello viewers, today with me is Professor Michel Jaboyedoff from Risk Analysis Group of University of Lausanne, Switzerland, and his research expertise is very known. He is having 7700 citations till date, and his area of expertise is geomatics and its application in analysis of Earth process such as landslides, and he is expert of LiDAR applications. His team has developed a flow R model for debris flow. So welcome, Professor.
Thank
So
you. Hello.
I'm going to interview today. I will be asking you a small questions, 3-4 questions. So your expertise is on LiDAR. So I will ask you the first question. That please enlighten us about this laser scanning technique or LiDAR technique and how it came into business of landslide mapping and monitoring.
Yeah, it started really not heavily, but at the beginning of the 21st century, the end of the 90s, it was developed, and then it appears, and then the first document that were start to be distributed with a 1 meter grid DM changed completely the life of any people who are working on the surface processes, because you were able to see with ill shade first, even not only an image of that data will give you a lot of information about the morphology, and especially for landslide, but also for survey of the roads, the highway, anything start to be really important. And then slowly it came into the business of landslide, but not so rapidly, because they are the two documents, the one that are coming from the airborne LiDAR, which makes these very nice maps, and which is very efficient to remove vegetation, and so that you have really the ground. Then this was one aspect, and the problem was that the countries are not all have not all enough money to have this data. Fortunately, in Switzerland, we get very early a coverage of the full country, and even it's renewed frequently. Now we have a LiDAR DM with 80 points per square meter, which is the airborne one, which is starting to be really incredible. And so there was also the other aspect, which was the ground-based LiDAR, which also started to be used for engineering geology, for rock stability, for monitoring instabilities, and so on. So it's at the end these really the techniques. It's I will say. The new research in landslide is a bit technologically driven, especially by LiDAR.
So you have mentioned some of the pros of this technology. So I would like to ask you, please give your insight on the pros and also on the cons of this LiDAR technology.
Yeah, the pros, I said that one of the main thing is if you have the full wave, it means that you have a lot of echoes when you send your pulse. Then when you have the return, you can get the ground and remove the vegetation, or you can work with the vegetation. That's also an important topic. In fact, it was developed in Switzerland for forestry, mainly because to address this was the main topic, which is more important in terms of environmental management and landslide. But this is the good point of this. The drawback of this is rather expensive up to now. This is the problem: is that a device is several tens of dollars for the small device, and tens of thousands of dollars, sorry, to buy one, and then it's 100,000 several $100,000 for good ground-based and long-distance LiDAR or airborne one. So it's expensive. It's in terms of for the tool itself, it's an issue. But we have to say that in the future, because of the development for the autonomous car, then maybe there will be the material will be a bit cheaper, and then I think the development can continue. That it's not sure it will be always so high in price. But the second thing is there is also, if you don't take, there are two problems now for acquisition. If you make the acquirement with ground-based LiDAR, you have often occlusion and hidden part that is difficult to handle. That if you are you don't see behind things, you don't see above that. And then if you have a drone LiDAR, then it's not a problem. If you have an airborne, the drone is the best because also now the angle of view is better, then you can have vertical cliff, which was not the case before. Then it's also evolving. There are some drawbacks that are disappearing slowly. But for the ground base, it's the main problem is the occlusion and the shadow that you have. Then also another issue is the color that you get from, it's not the LiDAR which is giving you the colors. It is an additional camera. Then you have to georeference, you have to adapt, not georeference, but to be in alignment with the LiDAR. So
that is the bottleneck of
yeah. But that's the main. But it's evolving fast, and it's very difficult to say what will be LiDAR in 5 years because of the evolution, especially with the
yeah, talking of the evolution and drones, I would like to ask you that in comparison with UAV photogrammetry or this structure from motion algorithms, they are coming and evolving. So and the drones are more cheaper than LiDAR. So where do you find the future of LiDAR technology in comparison to this drone photogrammetry?
Well, first I would say that they are complementary techniques. That I think that if you use both, sometimes you can get really excellent results because you have also a check, because as you know, photogrammetry is never really completely perfect. So it's good to have some LiDAR to check the quality, because with the LiDAR we know more or less that it's okay. Depending if the LiDAR is not in a good shape, then it does not work. But they are, first I will say they are complementary. Second thing, the photogrammetry for the main problem is vegetation, dense vegetation. Then we have some issues. For the street mapping, it's for sure that LiDAR now is less interesting, especially because also now the drone have good GPS, embarked GPS. They are cheap, the cameras are of high quality, and it will also improve gradually, that it will be very cheap to fly with this. So in many aspects, especially for if you have cliffs, if you have a landslide that have not too much vegetation, you can work rather fast with that. Now, I think that it's sure that LiDAR will probably be a bit less popular because it's expensive, but still, I think that there will be some application where LiDAR will be the best. I think for monitoring, in some case, it's not always easy to do that with drones. And we have also the monitoring of landslide, I mean moving landslide, is not necessarily the best solution, because LiDAR is, as an aspect of LiDAR, it's when you scan it, it's done. You have not the full treatment. It's sure that there are development also in both sides, and you see this is also the future. The development in LiDAR will be also something interesting, and the development that are linked to photogrammetry will be also something interesting, because you can automatize the photogrammetry, which means that you can monitor with picture. The drawback of both method is you need to have a good weather,
Yeah.
and And also photogrammetry is less efficient when the light is not so good, especially in natural environment. So I mean that I'm not sure if I'm in an emergency situation, if I have the both capabilities, I will take the LiDAR. Because I'm not sure I will get the result quickly. I will not sure that the weather will be good. And so then you see this is something, but it's sure that LiDAR, the photogrammetry and the SFM made a huge progress, and for first for teaching it's an advantage because a lot of students can work with that. It's cheap, and so I think it's really a very nice tool. And but the issue of both now is to develop more software to use this 3D cloud point, which is still not, there is not so much to.
And this is my last question. That what are your advice to budding researchers? You already hinted many things, that linkage of photogrammetry with LiDAR, then this mm, this 3D point cloud exploration of all these, then this you are telling about the color which are coming. So you can throw some light on this, that what is your advice to the budding researchers which are going to pursue in the field of LiDAR and its application on landslides?
I think there is a lot to do, especially in the treatment of the data. It's the most important. There exists the free software, Cloud Compare is very good for working on with CloudPoint. We can do virtual reality for communication. We can do a lot of things now. There is still a lot of work to do because, for instance, doing surface really triangulation with a huge number of points is difficult, and there is a lot of treatment to improve probably. There is a lot of method to analyze, for instance, the structures to detect, because there are a lot of attempts to detect the discontinuity in a rock massive, but there's not satisfactory result up to now. Probably there are coupling between this and also partially supervised, also because you have some trace, the picture, the image are important. There will be also developing a lot of modeling, because only at present the modeling of landslide, for instance, are only taking advantage of this cloud point is mainly how do you say rockfall, because it's not too difficult to model. But all this shallow landslide with detailed mapping or landslide, the software at present are not able to integrate that inside. So there is a lot to do in that. There is a lot to do in treatment, comparison, calculation of volume, deduction, and also improving the knowledge of the morphology of the object at surface. And so there is a lot to do there, I think, and we can extract more and also develop very automatic procedure. So, in my opinion, it opened so much things. For instance, if you look at, if you want to search water, okay, I think in India it can be an issue. So groundwater, you need a reservoir, you need to have a fracturing, you need to have or a porosity, and the characterization of the porosity or the fracturing can be done with this LiDAR. And there is also another thing. The 3D point clouds is not only the map of 100 kilometer of LiDAR, 100 by 100 kilometer LiDAR airborne. It can be 200-meter cliff or at that scale, but it's also the micro. There is also LiDAR, or I would say laser scanner, that are designed to make micro analysis with, now there are some scanner up to 50 microns. So we can go also toward the treatment of the 3D of micro surface to characterize especially rock mechanics, or even the you can maybe look at the permeability or the pores of something coupled with other method, but there is a potential to
A lot of
a lot of
potential.
things, yeah, but also not at all scale. It's not only large regional scale, but it's also at micro scale that it will be very interesting.
Again, from perspective of data, it is a huge data. So again, your data mining and all these aspects are also open for research
Yes.
in this area.
The problem in I think the problem with data mining for geomorphology and so on, it's very difficult because there are some, there are some dominant aspects that are, for instance, the slope. And then if you start to work with this learning machine and so on, often the result is you get a slope map because this parameter is so strong compared to the other you put that there are two there will be the flow accumulation and the curvature, but even the curvature it starts to be difficult because one thing which is not done yet, if you speak about there is one thing that now the learning machine is working mainly pixel. It's a pixel oriented, which is not adequate for working on learning environment. Because in a slope, you have the environment around the neighborhood. And once the method will include neighborhood, which is the case when you use the flow accumulation, which is a bit the case. If you integrate the neighborhood, then you will start to be able to use these techniques really efficiently. But up to now, what I've seen, it's often there is still a lot of work to do.
Okay. Thanks a lot, Professor, taking out time from your very hectic schedule for this interview. I'm really very grateful for this. Thanks a lot.
Thank you.